Now here we are flying in just absolutely beautiful weather, and you can do this sort of thing because you already know about the surface analysis chart and how it shows you pressure patterns and fronts, and you can figure out when you're going to have beautiful weather like this. Let's take a look at another very useful tool that's a weather picture that gives you at a glance VFR, marginal VFR, and IFR weather, and that is the weather depiction chart. And just like the surface analysis chart, it's prepared every 3 hours. Now notice, this thing depicts the weather that was actually observed, actually happening at the time of the observation. It's not a forecast chart. Now, you can use this weather depiction chart for a first look at general weather conditions, and sometimes you can make a quick no-go decision, which is really a no-brainer because you might find out your destination has widespread IFR weather surrounding it. You wouldn't want to do that. So the weather people have made it very easy for you to read VFR, IFR, and marginal VFR at a glance, and the reason they made it so easy is they put a legend down here. So let's take a look at the legend and see if we can figure it out. First of all, let's take a look at no contours down here. That's VFR. That's areas with ceilings greater than 3,000 feet and our visibility is greater than 5 miles. Let's take a look at that. If you look at an area with no contours around here, that's just plain old VFR weather. Now, if you go back to the legend and look again, you'll see the next area is a contoured area. Well, that's without shading. That's the first contour, and that's marginal VFR, and that's areas with ceilings greater than or equal to 1,000 feet or less than or equal to 3,000 feet, and or visibility is greater than or equal to 3 miles, to less than or equal to 5 miles. Let's translate that into English. That's marginal VFR weather, and that's ceilings 1,000 to 3,000 feet. That's visibility 3 to 5 miles. So that's inside the first contour when you look on the chart here, and you see the first contour is marginal VFR. So out here we have VFR. Here's marginal VFR. Now you might ask, what is this shaded area inside the second contour? Let's take a look at that. The shaded area inside the second contour is IFR weather. That's ceilings with less than 1,000 feet and or visibility is less than 3 miles. So let's take a look at that and see if we can make sense out of it. We've got it right here. Here's VFR weather, here's marginal VFR weather, and here's IFR weather. Now let's take a look at the whole country. And out here in the western part of the country, you notice there are no lines at all. This area, the whole area here, is basically VFR. On the other hand, let's take a look at the north central states, and you'll see that there's inside this first contour a large area of marginal VFR, and inside the second contour with the hash marks there is a big area of IFR weather. So there's a lot going on here. Now let's take a look at a trip we might make from central Arkansas, and let's assume we're going to go down from central Arkansas down to Alabama. Let's take a look at central Arkansas and see if we can figure out how to read this chart in a little more detail. Now, if you were going to make this trip from central Arkansas down to Alabama, let's take a look at what kind of weather you might have. Now notice the stations are shown just as they are on the surface analysis chart, and the percentage that this circle is filled in tells you what kind of clouds they're having. Here it's 3/4 of the way filled in. They're having broken clouds. Look underneath the station and the cloud heights are here. Just add 2 zeros to it, and these clouds are broken clouds at 25,000 feet. Now if you move into Mississippi, notice we have scattered clouds because we only have 1/4 of the symbol filled in. They're also at 25,000 feet. And then we get on over to Alabama. We're still scattered to sometimes clear weather, but scattered clouds here at 25,000 feet. And so if we're going to do this trip from Arkansas to, we'll say central Arkansas down to Alabama, you want to know what the weather was going to be like. Well, you would say scattered to broken clouds, and they're going to be, 25,000 feet almost the whole trip. Now let's take a look at Texas. I'll walk across Texas here. It can take a long time to walk across Texas. It can take a long time to fly across Texas. All right, let's take a look at eastern Texas. In eastern Texas here, we've got some IFR weather. And you know that because we have these contour lines with the dashes inside or the hash marks inside, so we know that's IFR weather. Now let me ask you a question. What's causing that IFR weather in eastern Texas? Well, you'll notice that we have the station symbol with an X in it, and that means the sky is obscured, but there's no cloud height, so we don't know how high the clouds are. But if you look to the left, there's 2 miles visibility, and that what looks like an equal sign there tells you that they have fog. So we know what's causing the IFR weather for sure. We know that it's due to visibility because it's only 2 miles visibility and they have fog. but it's probably not due to rain or anything like that because we don't have any symbols for rain. Oh, by the way, take a look at this bracket symbol up here in this station, and that bracket symbol tells you that's an automated station. So if you ever see this bracket symbol, it tells you you have an automated station. Now let's saunter up into the heartland of America. We'll go into Illinois and Indiana here, and you'll notice there's a front going through here. I want to ask you a tricky question. Which way is this front moving? Well, when you take a look at it, you see that there's alternating cold and warm front symbols on opposite sides of the front. What kind of front is that? Well, as you remember, that is a stationary front, and it's a stationary front all the way down into New Mexico. So let's go on, follow that stationary front all the way down into New Mexico, and look down here in southeastern New Mexico. And what do we got going on here? Well, we have an area surrounded by a line, but it's not shaded, so that's an area of marginal VFR weather. And as you can see by looking at the station symbol, the skies are overcast because the circle is solidly filled in there. And you also see that you have the number underneath here, the cloud height. And the cloud height is 6,000 feet when you add 2 zeros to that. Now, let me ask you a question. We said this is marginal VFR. What's causing the marginal VFR weather? Is it the clouds? Well, no. Marginal VFR clouds is ceiling 1,000 to 3,000 feet, and we have 6,000 feet, so the ceiling isn't making it marginal VFR. So what could be making it marginal VFR? Well, let's take a look on the left-hand side here, and on the left-hand side we see a 4, and that's visibility of 4 miles. Marginal VFR is 3 to 5 miles, so it is the visibility. It's making it marginal VFR here in southeastern New Mexico. By the way, we have a symbol for a thunderstorm there going on right there, and that's what that symbol is right there. Now let's take a look up in Oregon, and we'll take a look at the west coast, or the left coast as a lot of people like to call it, in between California and Oregon here. And what kind of weather do we have here? We have some IFR conditions with the contour line with the hash marks inside, and we've got really serious IFR, it looks like, because if you look up in the Oregon coastal area and you want to see what the clouds are, add 2 zeros to that and you find out we have overcast skies with 300-foot ceilings. But look at the visibility. The visibility is 5 miles. So what's making it IFR? Well, it's got to be the ceilings. We have these little 2 comma-like thingamabobs here, I think. And so that stands for drizzle. So we have 5 miles visibility and drizzle. So it's IFR here, but it's IFR not due to the 5 miles visibility, but due to that 300-foot ceilings. So as you can see, this weather depiction chart gives you the ability to get a quick snapshot of the weather, so that when you go on your flight, you can have good weather just like this. And so you now can control that factor. And you factor in this weather depiction chart into your go, no-go decision. It'll help you fly in the clear, making you a much happier pilot person.